I received a request over Piazza that this session should be recorded and then subsequently put up to YouTube. So I will do that once we have finished this review session. But yeah, so just a quick reminder of Teams etiquette. If you wouldn't mind muting your microphone when you're not speaking, that would greatly improve the overall flow of the session. If you have something that you would like to say, or you have a question or what have you, please raise your hand, and you will be called in turn. So I guess I should start with some general remarks about the exam. You probably are well aware of this by this point, but it bears repeating. The exam will be occurring in the same format as the tests. That is, it will be a 24-hour take-home format affair. It will begin at 9 a.m. on the day of examination, and it will end at 9 a.m. on the day after the examination, Eastern Standard Time. So, contrary to what the registrar thinks, we will not be starting the exam at whatever time slot they had given us. We will be opening the exam at 9, and it will be closed at 9 the next day in the morning, Eastern Standard Time. Are there any questions about any of that, or any organizational questions related to the exam? Perhaps it also bears repeating that the mechanism by which you may obtain the exam is, again, the same mechanism that you have been using so far to access the assignment and the test material. You log into Jupyter and fetch it via the normal process, or you log into Avenue and download it from the assignments page, pardon me, for filling out on your own local instance of Jupyter. So yeah. Could somebody please give me some kind of indication? Or oh, we've got a maybe. Oh, we've got a hand raised. Okay, so the feedback is working. Jeremy, you have a question.
Is there anything different at all about the administration or the accessing of the exam that's different at all from the first 3 tests? It seems to be the same.
No.
Okay, cool.
Yeah, the intention is that the exam will occur in exactly the same manner as the tests. It's just that it's an exam, so it's a little bit bigger and a little bit more complicated than any of the tests have been. That kind of blends us very neatly into our next topic of discussion, which is people like to have some idea of the difficulty of the exam relative to the tests. So you should certainly expect the exam to be more difficult than the tests. I'm sort of, as I'm designing the exam, I've kind of been shooting for something on the order of a 50% increase in the amount that's being tested, something like that. Whether or not, obviously the mileage will vary quite considerably from person to person as to how long any particular part of the exam will take them. But in general, I'm sort of shooting for about 50% more material in the exam than was in the, say, test 3. So, yeah, that's all the case. Just to get things started off, a review of major topics. There are, let's see here. Do I have a comment? No, I don't. Okay. So with respect to the first 4 lectures or so, you'll probably have the impression that this material is so fundamental to the course that it kind of is not. You can expect it to not really be tested explicitly. It's, there's no question on the exam that's like write a if statement, right? Or write a loop. You are expected to have internalized those procedures to such a degree that you now think in if statements and for loops, and while loops and all of the rest of it. And to some extent, you're also expected to think in data structures. So these things are not going to be tested explicitly, but they will. There's, I think, probably not one question on the exam that won't require that material in one form or another. So, so much for that. Moving on to the functions and recursion module, you should know that I consider the functions and recursion material to be a major testable topic of this course. It's kind of listed in the course description, so you would be well advised to revise or take a look at the recursion material. You should know what recursion is. You should know how to use it. Given a problem that requests a recursive solution, you should know how to do that. I would say that includes the material on memoization. And we can, go through examples. All of this stuff, the purpose of the review session is to go through some examples on topics that are requested by the persons in attendance of this review session. However, again, we're still working with the front material. So, functions and recursion, sure. Testing and exceptions. You can expect some exception handling. I don't consider exception handling to be a particularly difficult topic and not necessarily worthy of its own question on an exam. You will likely see the testing and exceptions material tested through other questions. So, if I'm asking you a question about file I/O, it's possible, in fact, probable that some kind of test, exception handling has been worked into that question or some other topic. Good. So there's also the, I think I skipped over the numerical computation stuff. So for numerical computation, you should know what the pitfalls are of floating point representations. You should also know how base systems work. So those first few slides where it's kind of the sort of theoretical slides within that topic, which cover the manner in which base systems work and the way in which base systems interact with sort of the decimal system, or the way that we use decimal points to represent fractional numbers. I would recommend those be topics of review for you. So much for numerical computation. Moving along to, I guess the next one would be classes. You can certainly expect some material on classes. Classes are, let me put it to you this way. If this course had two tent poles, it would be recursion and classes. So you can certainly expect classes to be covered. I would recommend reviewing the material on inheritance. I would recommend knowing how to build a class. Sort of using, methods and what have you. So yeah, so much for classes. moving on our next topics. So we sort of move into visualization, dates, and databases, although you don't really have to expect any testing on visualization. It's just about impossible to get the autograder to do anything with it, so generally speaking, we skip it. It's really more informational anyways. Obviously, the material on machine learning was not covered in great depth in the lectures. We sort of just skimmed over it. You can expect that I won't throw any of that at you. I feel like there's a topic I'm missing in the middle. Oh yeah, file I/O. Okay, yeah. So file I/O, you can certainly expect something as well. You can expect a nice big file I/O question that requires stuff. And you can also expect something about databases. So I guess in that sense, I will open up the floor to questions from the audience, either about the topics that are going to be covered, or if you'd like to start suggesting things that you'd like to have covered, then that's also a excellent use of the present. Oh, it switched me my camera back. That's interesting. Did it also do my microphone? No, just the webcam. Very strange. There. All right. So, let's see. Yes. So, what is your question? Oh, person with your hand up.
Hi. I was just wondering if you could go over a question with inheritance in classes.
All right. We could do that. Inheritance.
And just a follow-up about the test. Will we be given testing cases like usual to check our codes with?
Yes.
Okay. Thank you.
Shall I just proceed directly into the example, or would sometimes it's useful to generate a list of topics that everybody wants to hear about prior to yeah, what do you speak? I am listening.
Hi, are we gonna be expected to do any database stuff on the exam?
Yes.
Then can we go over that?
I can throw that up. Yep. Database stuff. Okay, we can review databases. Right. Next.
Can we go over some recursion?
Some recursion. Yep. Anybody else got anything? Is that enough for now? Okay. Well, we can start. That's certainly enough to get started. So I'm just gonna give me a moment to get my system oriented. Let me open up a file that we'd start playing around in. How has the exam period been treating you guys anyway? I'm soliciting general comments. You can turn off your mutes to you know. I'm trying to engage the audience here. Nobody really has anything to say about it? Everybody kind of just wishes it would be done already?
I think it's been pretty okay. Well, given that it's a pandemic, I think it's harder to stay motivated at the end of the year, than it usually is. Like, it's always harder at the end of the year, but the pandemic and the lockdown kind of makes it even more difficult.
Always whenever the weather gets nice.
Yeah, that's true. It's pretty nice outside today.
Just to
Yeah.
backtrack quickly, you said no to visualization being tested. Did you say anything about dates? I might have missed that.
Dates are open. Yeah, dates are possible.
Thanks.
Yeah. I wouldn't consider it a major topic, right? Like, if there's a question on dates, it would probably be more like a 4-point question than an 8-point question, if that makes sense.
Yeah.
Still, though, 4-point questions definitely add up. So let me just share this little old screen of mine. All right. You guys can see this? Yeah?
Yes, we can see it.
Good. Excellent. Thank you. You know, when I said you know, keep your mics muted and raise your hands, it's kind of like maybe I was being too strict. You know, it's difficult to have like 30 people talking at once, but maybe we can have comments without having people having to raise their hands first. Because I like this. Ideally instantiated, this should be a conversation, right? So we were going to talk about inheritance first. Inheritance. So just to review the basics, think back to our slide material on inheritance, right? We were talking about a point class and turning it into a colored point by adding a color attribute to the existing point class. The purpose of inheritance is code reuse, right? The idea is you have classes that define useful things, and in order to minimize the amount of work it is to create something that is a variation on that original class, rather than completely redoing everything that's in the base class or copying and pasting. Generally speaking, if you're copying and pasting code, you're doing it wrong. We use a mechanism that's known as inheritance. So let me just come up with a new example just off the top of my head. Let's say we had a class Feline. Inherits nothing. We're going to define it felines. What are some things that felines have? Anybody?
Fur color?
Fur color. Very good. Self.fur color equals, maybe we can, let's just not initialize anything, make it easier. Let's say orange. Something else a cat, or something else a feline has. Not a cat, a feline. Something like more general.
Eye color?
Eye color. Sure. And let's get one more.
Breed or species?
Let's leave that one off for just the moment. Let's think, when we're talking about the feline class and attributes of the feline class, we're talking about properties that are common to all felines, right? So what's a thing that all felines have? I would say something like rough tongue equals true. Something like that, right? Because all cats, cats as sort of the feline family, all members of the family feline have these sort of barbed tongues that are used to rasp meat off of bones in the wild. So I think that's good enough. So we have a class feline that has these attributes. Fur color orange, eye color yellow, and they have a rough tongue. You can imagine many more specific types of felines that would have these attributes, right? You might say, a lion could have these attributes as well as a house cat, right? So, let's actually define some classes that inherit from feline, right? So let's say we have a class lion, right? And we'll initialize some properties for this. And I know I haven't included any methods just yet. We'll get there. Let's just focus on attributes for the time being. So what are some things that a lion has that are specific to lions, but are not shared by felines?
A mane, like the fur around their face.
Yes, self.main is equal to true. Sure. Anybody think of another one? Something a lion can do, or something that a lion has, because we're talking about attributes, that a general feline does not have.
A roar?
Yes, but since roaring is an action, let's save that for methods. Something else? Anybody?
How about large teeth?
Large teeth. Sure. We could even say something like size in general. We could say self.size is equal to lion size. Now, every feline is going to have a size, right? But one of the interesting things that you can do with inheritance is you can take attributes that exist inside of a base class, and you can assign them different values that pertain to the particular the derived class. So that's I don't know if we talked about that particular nomenclature in class, but then this sort of derives more from C++'s the way that C++ uses classes and names things in classes. But it's a good way of thinking about it. The class that inherits the class that is inherited is sometimes called the base class, and the class that does the inheriting, pardon me, is sometimes called the derived class, because it is derived from the base class. And of course, I have forgotten the most important part of all of this, which is we have to actually inherit from feline. So in Python, when you inherit a class, you have to put that in the parentheses. So there you go. Now, this is good insofar as it goes, but we have to perform one more step in order to actually initialize lion as a feline as well as a lion. And that is, we have to make reference to the initialization method of the feline class within the initialization method of the lion class. So we can do feline dot init. So notice we're making reference to the we're using sort of absolute method addressing via class name rather than via object, right? Because remember that self is an object of the class that you're defining, right? You guys with me so far? Can I get a thumbs up?
I have a question. For the self.size in the base class, does it have to be something or can it be an empty string?
No, it could even be a none.
Okay.
Yeah, it doesn't have to be any particular thing. It's just you know, if I look at the idea of a size, you know, from an abstract point of view, it's not like felines don't have sizes. You know, it's more like if you're talking about lions have a typical range of sizes, right? House cats have a typical range of sizes. Felines in general have a much broader range of sizes because it would be inclusive of all of the different members of the feline family, right?
Mm-hmm.
To some degree, the analogy starts to break down a bit when we start talking about that sort of thing, but hopefully you guys are all following so far. So, So let's talk about methods then. If we define a method that is an action that all felines can perform, what might we say? What's something all felines can do?
Eat?
Sure. Can we get something a little more specific? Because that's something that applies to all life forms, almost.
Would it actually, wait, this might not be that specific, but I guess hunting, so being a predator?
Yeah, we're closing in, but what's like maybe we can make that even more narrow. Because you can imagine like a class feline inherits from called you know, carnivore. Right, that would define all of the behavior related to hunting, right? That feline could inherit from carnivore. But what's something that a feline does that is specific to felines?
Purring?
Sure, excellent. That's a good one. So define purr, self, and you know, it doesn't matter what it does. Set mood equals happy or something like that. Or if mood equals happy, vocalization equals true, something like that. So what's something that, actually, we already talked about this. So one thing that a lion can do, and it's actually a feature common to a subclass within the feline family, but we'll assume for a moment that lions are the only felines that roar. Roar is a thing that a lion can do. And again, it doesn't really matter. I'm not caring to, well, maybe we'll have some interaction so that we can actually use these methods. So purr is going to print purr, and roar is going to print roar. There we go. So, cool. So now that we have these methods defined, we can let's actually invoke them and see where the levels, like we'll see what has what, right? So let's have my cat as an object of the class feline. And let's have my lion as an object of class lion. I should really capitalize these, actually. Conventionally, you capitalize. So I should do that. Right. So
you forgot to capitalize feline in the lion inheritance statement.
Ah, thank you. Wonderful. So if I wanted to make my cat purr, I would do so. Let's see what happens if I want to make my cat roar. Let's do the same with my lion. Load that up into Python. What did I call this thing? Review.py. So get the purr method working for my cat, but when we hit this line 28, my cat does not have the roar method defined. Feline does not have access to the things defined inside of the lion class. So inheritance is a one-way relationship. However, lion does have access to both roar and purr. So the lion class has access to everything that it defines itself, as well as everything defined within the feline class. That is inheritance. Any questions about any of that?
I had a question, not exactly about this, but related. How do you call one method in another method inside a class?
That's an interesting question. So let's say we had like def roar twice or something, right? If we want to do that, then you have you would be calling the method in the same manner that you would be initializing something from another class. Basically, you treat the class you're in as if it were another class, which is kind of weird. But so lion.roar self lion. I believe this will work. If not, I'll have to look up to see how it works. But I think this will work. Yeah, there you go. There you go. That works. So we are, in fact, sorry?
You could also do self.roar if you wanted. Without passing in self, yeah.
Yep, that works too. Yes. So, and again, these are kind of equivalent constructions. The difference, of course, up here within the initialization function is if you do self.init here, you're kind of referencing the same thing that you're in, and that kind of makes it into a recursive call that you probably don't want to be in because it would just go on forever. But yeah, you can refer to the object that you're in either by using self, or you can access the method sort of from the class definition itself, passing in the object that you wish it to operate on. So the answer, I guess, is kind of like more or less the same way as you would do it outside of the class definition, just using self instead of whatever the object that you would have used. Using self instead of the object that you would have operated over originally. Something like that. Anyway. Does that answer your question? Do we have any other questions about this stuff? Someone in the chat? Yeah. Yeah. Yes. Gender/sex, Mark, I would say that's an attribute that is shared among a great number of organisms, not just felines. And yes, Mark is correct in saying the technical term for what we're doing here with self.size is overriding. So the definition, like size, as defined in the lion class, overrides the definition in feline. You could even say that the redefinition of the initialization method overrides that which is defined inside of the feline class. So when you have a class that inherits from a base class and the derived class provides a new definition for something that's already been defined in the base class, what ends up happening is the system will always go for the sort of the most local definition of whatever that thing is, be it an attribute or a method. So in that sense, it's correct to think of the new definition as overriding the old one.
Nick, I just typed out your code in a Python terminal, and you do not have that correct. If you were to print mycat.size right now, it will print none because you called feline.init after calling self.size.
Ah!
The
order
of initialization does matter.
Oh, well, there you go. Thank you, Mark. Mark is much better at Python than I am. Well. All right. See, this is why I hate Python classes. Anyway, so yeah, if there are no more questions about that, I think I'll go and do recursion next. Skip over databases and come back to it, hey?
I just have one last question. If you call on a method in another class inheriting from feline, for example, if you call on roar for another class, would it work the same way as you did with roar twice?
So you're saying, like, if I had class house cat or something like that, that also inherits from feline?
Yes.
Yeah, so because roar has not been defined in the feline class, housecat does not have access to it through self-dot, right? But and you also would need, I think, an object of the lion class in order for the method to operate on. So you can't, I don't, maybe Mark can correct me here. Sir, I think you would need an object, you'd need a lion object in order to call roar over, in order to be able to use roar inside of the housecat class. You'd agree, Mark?
Yeah, the very first thing that happens when you did lion.roar and you pass in self where self is a house cat is it immediately checks if self is instance of lion, and if that fails, it will error.
There you go. So does that answer your question?
Yes, thank you.
You're welcome. Yeah, so the takeaway then, you really should view the these two different things inheriting from feline as being two branches of a tree, right? They don't share information. Any information that you want them to share should be inside of the feline class. That is the purpose of having the base class that both of them inherit from. So if you want roar to be accessible to both lion and housecat, you really should be putting it inside of the feline class, even though that kind of breaks what a feline is according to nature. But then again, housecats can't roar, so. Cool. Any other questions about inheritance before we move on to recursion?
Yeah, just one quick question. I was wondering what like the difference is between like dot super and inheritance.
Sure. Mark, do you want to take that one?
So super is a form of referencing the parent class without knowing exactly what it's called, only when you have one parent. So lion could call feline super because feline is the superclass and it is the only superclass. But if house cat inherited both feline and lion, there is no super. There is no one super. So therefore, you would have to specify what class you're talking about.
In my understanding, it's kind of shorthand for the base class for this class. Whatever that might be. Cool. Does that answer your question?
So, like, how would you specify using dot super if you had multiple objects of multiple inheritance?
So, I think you wouldn't. You would refer to them by the specific class names that they pertain to.
So, like, what's like the overall purpose of using dot super then versus just like having regular inheritance?
I mean, it's not so much like, I don't think you should view it as being something separate or different from regular inheritance. It's more like a syntactic. It's more like syntactic sugar, right?
It also is great if you're working in large projects and you forget what the parent object is, but you know it only has one. So you could just refer to it as super and move along. And it's also extremely copy pastable.
Mm.
Okay, thank you.
Cool. Any other questions about this stuff before we move along? Okay. All right, I'm going to move on to recursion then. Going once, going twice, going 3 times. Done. Sold. Recursion. So recursion then. Recall from the slides, recall from the topic that the way that we define recursion is as an inductively an algorithm with an inductive structure. That is to say, an algorithm that has both a base case and an inductive case. So, the classical example, of course, is factorial. So n factorial is defined as n multiplied by n minus 1 factorial. And 0 factorial is defined as being 1. So because we have defined the equation for factorial using factorial in that expression, we this becomes an inductive definition. So the problem, of course, with an inductive definition is that we would get, if we wanted to do 5 factorial, that would be equal to 5 times 4 factorial, which would be equal to 5 times 4, 5 times 4 times 3, etc., times 2 times 1 times 0 times -1 times -2, all the way off to negative infinity. So the problem with an inductive definition is that it requires both this case where it's being self-referential, and it also requires some point at which to stop. So with factorial, we have defined that point at which to stop as being 0. So once we hit 0, 0 factorial is defined as being 1. So we can perform that substitution, and now we are left with an expression that no longer contains the factorial expression, so this this definition ceases to be circular, and we can just compute it. So recursion is a way of doing this in computers. The particular manner in which we do this typically is using functions which call themselves. So if we were to define a factorial function to use recursion, it would have to call itself at some point. It would take some argument n, just as the factorial operation does, and we would then have to immediately differentiate our base case from our iterative case. So in the case where n is equal to 0, we have that's our base case, right? We know in that case that the value of the factorial of 0 is 1. So we just, from that base case, return 1. Otherwise, we return whatever the value of n is multiplied by a recursive call to factorial. So recursion, in general, is a function which calls itself. And when you make a statement inside of a function that performs an invocation of the function in which that statement exists, that is the recursive call. So there we go. So if we call factorial over 6, or we give it 6 and print that, there we go. And I've made a error because this needs a pass. The value is 720. You can verify that on your calculators if you like. So that's like the general form for recursion as derived from an inductive mathematical definition, which is sort of one of the ones that we primarily focused on during the course. It should be noted that recursion is a more general technique than that. You base, like, any function which calls itself is recursive, and you can have all kinds of interesting applications of it aside from these sort of very trite mathematical definitions. For example, you can compute a sum recursively. So let's say we had a list L and we wished to compute the sum of that list. We could say that if the length of the list is 1, and the sum of that list is return whatever the value of the 0th element is. Otherwise, we may say that the sum of the list is the value of the first element added to the sum of the remainder of the list. So that would be from 1 to the end of the list. I believe that'll work. So if we print, so if we create a list queue and just do something quick, range from 60 to 92. There we go. Actually, we can break this down a little bit with print statements to view what's actually going on. So print L is equal to, and then whatever the value of L is. So you can see, I'm going to just narrow down that range just a little bit so it's easier to see. 78, sure. So you can see that on our first invocation, we've got the full list, right? We're going all the way from 60 to 77. Because remember, the range, when you create things with range, it's exclusive of the second number that you give it. The second time we're calling sum, L, it has the first element chopped off. And then you can see that we continue chopping off the first element until we have reached the case where L is just a single element. Since L is just a single element, we have a non-recursive solution to what the value of the function is, which can then be passed back up through the chain, and you can come to an actual conclusion about what the value is. So with respect, like in recursion, you always have to keep in mind like what it is that's changing between iterations, because if you make a recursive call and you don't change anything between, like, if you were to do something like this, right? Factorial of n is equal to factorial of n, then it's just going to step into that definition forever. Like it never reaches a conclusion, because you haven't defined the case using inductive reasoning. You have defined it using a what in logic we call a tautology. You've defined something by saying it is what it is. You know, the color red is the color red. That's not a useful definition. In computers, it's not a useful definition because the computer is not intelligent enough to realize it's been given a tautological definition. When you give a human being a tautological definition, they're usually well, that's stupid. But a computer will believe you that you're giving it a real definition each time because they're very dumb. So yeah. So yes. So that's recursion. Are there any questions so far? Ugh. No? Okay. All right. So in that case, I'll just quickly go over memoization because, I have my reasons. So the problem, one of the problems that you get into with recursion is when you have a recursive definition that requires the requires more than one recursive call per run through of the recursive algorithm, per iteration of the recursive algorithm. So the classical example of that is the Fibonacci sequence. So we know from math that the way that the Fibonacci sequence is defined is each element of the Fibonacci sequence, except for the first two, is defined as the sum of the two preceding numbers, right? So we have 1, 1, 2, 3, 5, 8, etc., right? So if so for the first two elements, if fib at 0 equals 1 and fib at 1, this is just pseudocode, equals 1. Otherwise, fib at n is equal to fib at n minus 1 plus fib at n minus 2. So the problem with this is that start running into large numbers of iterations very, very quickly, because you're sort of each time you call fib, you're generating at most 2 more calls to fib, right? And then you're only really not generating 2 more calls to fib when you're in the base case territory. So fib n if n is equal to 0 or n is equal to 1, return 1, else return fib n minus 1 plus fib n minus 2. And just for the sake of interest, we'll keep track of how many times it's been run. So we'll call it count is equal to 0. Global count plus equals 1. Print fib 5. Print count. So, when we compute the Fibonacci, the 5th Fibonacci number, we get 8. There we go. Notice we started counting at 0, right? So that's correct. We have 15 different recursive calls to this function. This function is getting called 15 times. If we increase that, 6, get 25 recursive calls. 7, 41. 8, 7. So and by the time we hit something like 20, we're talking like very, very large numbers, right? It is unreasonable for it is unreasonable to have called this function 21,000 times in order to compute the 20th Fibonacci number, which you could easily do by hand, using less than 20,000 operations, shall we say. So the observation that it enables memoization is essentially, while we have a very large number of these operations existing, very few of them are interesting. That is to say, very few of them are unique. We can actually put a hard cap on the number of unique Fibonacci numbers that must be computed. That's equal to n, right? Or 1 plus n if you count 0. In order to compute the Fibonacci number of 7, you need 0, 1, 2, 3, 4, 5, and 6, right? So this is kind of, this is where, if you weren't working on a recursion question, you might say, well, then the obvious way to proceed would be to just write a loop that computes it in the normal manner. But since we're working on a recursive problem, we must do things recursively. So the way that you solve that is by keeping track of intermediate calculations, i.e. keeping a memo. So a memo is a dictionary into which you store previously calculated values. The memo is common to all calls to Fibonacci because when you're including a memo in this manner, you're using an alias, right? So the data structure, you can think of the data structure, my brain wants to say malleable, but I know that's not the word. Mutable, yes. So this mutable data structure exists somewhere in memory. All of the calls to Fibonacci are going to hold on to a pointer to that data structure. So they're all going to be modifying the same data structure, which means they have this kind of common pool of knowledge, which they can all use and contribute to. So the way that it works, before we make our recursive calls here, we check to see if the call we're about to make already exists in the dictionary. So if memo at n-1 in, or sorry, if n-1 is in the memo, remember, the in operator over a dictionary checks the keys, not the values. Not in, actually. Then we want to add it to the memo. So memo at n-1 is equal to fib n-1. We only make the recursive call if the value that results from it does not exist inside of the memo. And then we do the same with the second one there. There we go. Then, rather than using two recursive invocations within the context of one return statement, we can simply make reference to the values as they exist inside of the memo, because we know that they do, because that's the whole like, we can't get past these if statements without these values having been assigned, right? So yeah, there we go. Now, if we invoke the same method, we get the same value, but we have only used 21 recursive invocations of fib, which is success. That means that everything worked. So yeah, that's memoization. Are there any questions? How many people are still here? Oh, we got a hand up.
Yeah, I'm just wondering about like the dictionary like object, like the memo object. Is that being stored globally, or is it being like, or is like a new one being created every time the function is being run?
So the way that I've got it organized at the moment is it's a argument with a default value, right? So if we wanted to, we could provide one, right? We could set up a memo that had some values in it already. So memo at is equal to, like, 4 is given the value of whatever. And then if we give it that memo, we can actually maybe not. Interesting. Well, at any rate, so the way that it works, the way that it's working at the moment is, oh, I forgot an important step. Yeah, so it's kind of implicitly using it globally here, but what you should do is you should not forget to actually pass the memo into the recursive calls. So if you remember to do that correctly, you can pass a memo in that has values in it already. If you put it in for the argument that has a default value. If you omit that argument, then at the top, for the top level recursive call, memo is sort of initialized as an empty dictionary. For all subsequent ones, the memo is being written to and being passed along, right? So in subsequent recursive calls, it's going to have more and more of these values. But yeah, does that answer your question?
Yeah, that makes sense. Thank you.
Cool. Any other questions?
Can I ask a question?
Go for it.
Awesome. So what is the point of using a memo as opposed to just an empty dictionary?
Oh, a memo is an empty dictionary. It's just a naming convention.
Oh, I see. So you could equally just like name an empty dictionary as like a variable and then append to the empty dictionary as you do your thing.
Yeah.
Okay.
The memo, what makes it a memo is how you use it, not what you call it. You could easily call it apple strudel and it would do the same thing.
Got it.
Can I also mention a memo does not always have to be a dictionary. It is just the easiest to teach. So in my
Yes.
second year course, I'm actually being taught a backpack sorting algorithm that uses a list memo. So instead of a dictionary.
Got it.
Mhm.
Also, I don't know if there's already a set list. But I was kind of wondering if we could look at the checkers question from the yeah. I've been trying to
Nick, should I
make
just
more
take my
stuff.
old YouTube video and release that again?
Yeah, sure. That's good.
Yeah, so Mark did a pretty extensive run through of the checkers question, which we kind of we suppressed the knowledge while it was an assignment question, but I think that would be super useful if you were to re-release that, Mark. It's like 40 minutes, but it takes that time to properly go through that question. So.
Okay, that would be great. Thank you very much.
All of my review videos that I've recorded have not managed to be less than 40 minutes.
That's because you take the time to do things properly. Cool. So yeah, are there any other questions about recursion in general, memoization in general, anything at all?
I just wanted to confirm your code. Can you go back to the code?
Yes.
So in the line where you're putting memo again, in the previous time you didn't do it. When you did if n-1 not in memo, you did memo n-1 is equal to fib n-1 memo. In previous, before you didn't put the memo and you still got the same answer. So what's the difference between adding that and not adding that?
Mark has probably a better idea of what the what the weird Python wizardry that's going on there is. To me, it doesn't make a whole lot of sense. To me, if this is left off, then what should happen is it gives you a blank dictionary again, which effectively, that would effectively turn this into the non-memoized version. But for some reason, it keeps it as a global variable, something. I'm not sure.
It's not a global variable. Python has been implementing a automatic pointer pass-through, where if a global variable gets redefined in a function, the pointer to that gets to replace the default value. Okay.
So the answer to that question is too complicated for this course because we haven't talked about pointers. We kind of have, but yeah.
Okay, so the better way is to include memo?
Yes.
Okay, thank you.
Yeah, just because one of the things that I find to be the least one of my least favorite parts about Python as a programming language is it does a little too much to cover your ass, in my opinion. If you were trying to get away with this kind of crap in C, you would never be able to get away with it. But because Python does all of this dynamic stuff, dynamic typing stuff, and it does all this stuff in the background to try to make up for stuff, it can often do things that it's I have no idea why you're doing that. This doesn't make sense. And it's because something's going on in the background that you aren't aware is going on in the background. But some of us prefer programming languages where everything is upfront about itself and explicit. But then again, Python is an increasingly popular language, so I suppose they're doing something right. Yeah. So, are there any other questions about recursion?
The person with their hand up, just go ahead and speak.
So if you remove the if n-2 column, would that make a difference, or would it continue to work?
Remove the n-2 column.
Like
What do you
if n-2 not in memo.
Oh, this guy?
Just remove.
Well, in this particular instance, I believe you'd get away with it, because the way that this first statement works is this is going to recursively go through each element in the sequence and generate it before you ever get to this second if statement. So this is really just kind of, this is here for safety, if that makes sense. This is here in case the thing doesn't perform exactly the manner in which you expect it to. Like, we can reveal this behavior if we print some stuff.
It should be pointed out, in the specific case where n is equivalent to 2, I'm pretty sure that you do need the if statement of n-2 not in memo, because fib of n-1 does not go further down to the case where fib n equals 0. It goes to where fib n equals 1 and immediately terminates. Meaning that in the specific case, the only thing that your fib n-2 does is handle the 0 case.
Mm-hmm. Yeah, but it's kind of like a quirk of the math rather than like in the old days of programming, you would rely on those types of tricks for optimization all the time. But yeah, you can see the way that, so you can see from the pattern of invocations, we are starting at 20, going all the way down to 1 and then 0, and that the majority of these are n-1 invocations, except, as Mark points out, for the case where n is equal to 1 or something like that. So the other way that you could have solved this problem is by placing 2 entries in the dictionary, right? So if you said 0 is 1 and 1 is 1 in the dictionary ahead of time, you could probably get away with not having the base case in here at all, because the base case is implicit in the memo. Let's see if that works. Yeah, that also works.
Okay, thank you.
Yeah, so yeah, in the olden days of programming, you would often rely on those types of leveraging of the specific intermediate states and things like that. And maybe Mark disagrees with me about this, but it's better to have code that is readable than code that is sort of highly optimized in most cases, especially if you're working on a collaborative project. Like the more sort of hidden implicit rules you're taking advantage of, you're sort of assuming and relying on other people who might need to read your code also knowing and those rules, which they very possibly may not. So it's more courteous, I'd say, to write your code slightly less efficiently but slightly more readably, if that makes sense.
I completely agree with that in every language except Python, because Python's not a compiler language.
That's fair.
Because if you were doing it in C, no matter how bad you write the code, the compiler is going to compensate for you and optimize it. So you
Yeah.
have that kind of luxury.
Mm.
Python doesn't handhold.
Yeah. Yeah, that's true, isn't it? You don't have an optimizer on Python.
Yeah, because it's an interpreter, it codes line for line regardless of what you type in.
I would say, though, even still, like very like a lot of the time, unless you're doing something like really big, you know, where optimization is required. Like I would say optimization is generally not like it's not a hard requirement for most projects, especially the sort of projects you would do within sort of a university course context. Like certainly you can blow out, you know, there's a reason we're doing this memoization example. But for most things, I would say focus on communication over optimization. But, you know, what do I know?
Out of curiosity, could you switch the n-1 and n-2 statement and see what it prints?
Yeah, absolutely. There you go.
So it's a lot more flip-flop.
Yeah. Yeah, it'll go through and do all of the every second case and then backfill all of the odd numbers.
Well, it makes sense because every other n-1 is an n-2 case from a previous iteration.
Exactly. Numbers. Cool. Mark, you put the link to the YouTube video on checkers there in the chat.
I also put it on the Avenue for everyone.
Beautiful. Yeah, I would say that reviewing the checkers question is a good use of your time, students. Wink, wink, nudge, nudge.
Also, I apologize. It's not 40 minutes. The video is 1 hour and 1 minute long.
Yeah. So we, if there are no more questions about recursion, then I think we can move on to databases. Yeah. Cool. Cool. All right. Let me just unshare my screen for a moment so I can load up Avenue and stuff. So you guys can't see how many characters there are in my password. So how's everybody feeling about the exam? What are your, like, subjective impressions?
A little bit scared.
Okay.
I've heard horror stories of, I don't know, it being really long or the average being low, but I don't know. Preparing is going well at least, but a little nerve-wracking.
Last year's exam did not get a great reputation. That's 100% for sure.
Yeah. Well,
it was what, five questions, one question being 50% of your grade, and the shortest writing time for a student was 4.5 hours.
Yeah. Well, you know, I was actually, you know, despite all that, I don't think the grades were actually that bad. Like, I think it was
no,
like
the final average was like 73 or something.
Yeah, which is actually believe it or not, that's actually pretty high relative to the types of exams I was setting before the pandemic occurred. Like, it does seem that there's a bit of an advantage when you have the ability to look up, you know, information in the slides and such.
I also think it's fair to mention that we're being a bit more merciful, considering that no one's really a comp sci main in this course, so it's a lot easier than last year's.
Yeah. Not too easy, though. Yeah. But yeah, no, it's like... Yeah. Well, like, you mentioned the checkers question. That checkers question was the big question on last semester's exam, so that should give you some context. It was so good, I had to find somewhere to squeeze it into an assignment this year. Because I really do like the question, you know.
I am a lot more of a fan of these questions where it's a game and not just a computation.
Mm-hmm. Well, it gives you something visceral, you know, something you can really sink your teeth into.
Sorry, I have a question. For the big questions like the chess, will we have a breakdown of the question to do like we did on the assignment, or is it more of just here's a question, write a checkers board, and then we just do it without guidance?
The question as expressed in the assignment was actually the same as it was on the exam. So the way that it broke down the methods and like what the attributes you should have are and all of that kind of stuff, that is par for the course. I'm not just going to say write checkers on the exam. That would be unreasonable. Not in a fourth-year course, but in a first-year course, that's unreasonable. So yeah, so talking about databases. So you're sort of, the database material, I don't consider it to be, in terms of difficulty, I don't think it's the highest difficulty stuff in the course by a long shot, especially during an open book exam, because if you look at the slides here, pretty much anything that you need is going to be like almost exactly verbatim out of the slides. So if you need to create a table, use this slide to guide your creation of a table. If you need to view a table, use this slide to help you, you know. If you need to insert stuff into a table, like in terms of like query formulation, like all of the queries that you could need have analogs inside of this slide set. So so yeah, it's mostly a matter like of having used them a couple of times to sort of know what it is you're looking for, you know? It's like you need to speak the vocabulary, but in terms of like getting the exact syntax down, I wouldn't necessarily like syntax memorization. I don't think is necessarily a profitable use of your time when you can just look stuff up in the slides, right? Now, it is entirely possible on the exam that you're going to have to acquire data from a database in Python and then do something with that data. So I would recommend looking through the section on SQL in Python. Again, it's pretty straightforward. All you really have to do is copy pasta some stuff from the slides and, you know, make sure that it works. But it's, you know, it's, you know, I view it to be straightforward. but yeah, yeah. Anyway, for the person who asked me to cover databases, do you have anything more specific than databases in general that you'd like covered?
No, it was just like that's the least study part of my exam review right now. So it's just like, oh, maybe it would be helpful if you went over it.
Well, I think that you're probably studying correctly then, because again, as long as you have the broad strokes of databases, like the code itself is in the slides. So I guess just quickly to review what a database is, the correct way to think about a database is as a spreadsheet. So think of it like the same way that you would think of an Excel spreadsheet. An Excel spreadsheet is organized into sheets, rows, and columns, and a database is organized into tables, fields, and entries, respectively. So where a sheet in a spreadsheet might be something like, this guy, the movies table, or, it's getting away from me. This movies table would be one sheet in a spreadsheet, right? So the other thing to keep in mind about SQL is that fundamentally everything is operating on a command line interface, right? So when you create something, when you destroy something, when you view something, when you modify something, everything boils down to a command which is executed. And when you load up SQLite 3, that gives you an interface for entering those commands, right? When you open up a database object in Python and open up a cursor and send that cursor commands, you're doing the same thing, just in a Python setting, right? Does that make sense?
Yep.
Cool.
Yeah, that makes sense.
Right. Are there any other questions about databases?
If you're asking me, no.
I'm opening the floor up to anybody who may wish to. Anybody who may have a question.
I'm also just going to point out I dropped a link to the SQL Zoo real quick in the chat. Practicing select statements on that, I'd heavily advise it.
Yeah, there we go.
Sorry, just also one more quick question while we're on databases. SQLite is normally used with CSV files, right? Or are we expected to be able to? Or sorry, maybe not CSV files, but something similar in structure, correct?
So you should view the file I/O stuff and the databases stuff as being separate topics.
Okay, so we won't have to import a file and then have to convert like a JSON file and then convert it and then use it as a database kind of thing.
Well, I'm certainly not saying that. In fact,
there's a difference between imagining a database as a file and converting from database to file. There is nothing that stops you from doing the conversion. It's just a database file is completely unique in terms of how it's structured.
Mm-hmm.
Okay, that makes sense then.
You should in your brain, you should abstract the data from the mechanism by which it's being stored, right? So if I have this amorphous blob of data, storing it as a JSON, that imposes a certain kind of structure over it, right? But fundamentally, the same data can be stored in a CSV file or a JSON file or in a database file. It's just the means of access are slightly different in each case, and the organizational structure is different in each case, and different organizational structures are more useful or less useful for different applications. But, you know, the data itself is a thing that you can view as, if the data itself wasn't like this thing that could be removed from the particular manner of its implementation in a particular file, then you wouldn't see things like I think in the practice exam material, there's a question where you, like I've asked previously on the exam, take something that's in a CSV and put it into a JSON. And stuff like that.
This is very similar to the argument that keeps coming up on all of the tests about data structures and about like, well, there's tuple and there's list and there's string. And at the end of the day, data's data, and converting between data sets is very similar to converting between files.
Mm-hmm. Yeah, like materially speaking, most of the time, it's not going to matter whether you're storing data in a tuple or in a list, unless the particular application is sort of leaning on the difference between a list and a tuple, right? Like, if you really, really need that data to be mutable, then you should put it in a list versus a tuple. But if it doesn't matter one way or the other, whether the data is mutable or not, then you don't really have to worry too much about whether it's in a tuple or it's in a list. And certainly in Python, the operations are largely common to both representations, right? Python doesn't seem to care very much whether it's in a tuple or a list. It'll allow you to execute the same operations over it in either event. Most of the time. But yeah, like, and that kind of gets into one of the soft skills that you should have indirectly acquired by taking this course in computer science, is you should now have an idea of data that's more, you should recognize the difference between the data and the medium of its communication, right? But yeah. Yeah, anyway, are there any more questions? Do we have any hands up or anything? Cool. Well, if there are no more questions, I'll ask, are there any other topics that you guys would like discussed? I thought that was a question for a moment. Okay. Well, if there's nothing further, then I guess that's it.
Would you be able to cover something from file I/O?
Sure. Sure
I was
thing.
just wondering if there was a way that we could like directly index specific rows of a CSV file, or how that would work.
Yeah, you would. Yeah, you can do that. Let me pull up the slides. I think it's in the slides. Should be in the slides.
I also recorded a review video on File.io, which was posted as an announcement, which you can refer to as well.
Ah. Mark, you're the best.
And in fact, one of the specific things I did was cover the profit question from, I think it was assignment 9 that did the profit question with the CSV file. That might clarify some of the questions he might have.
Mm. Cool. Yeah, well, I'll if you want to post a link to it, that would be fantastic. In the meantime, yeah. So to answer your question about how you would like directly index the rows of a CSV file, it is important to recognize that this for loop, which is, you know, we're printing each row in the CSV file on a sort of, we're going through each of the rows and printing them using a for loop. You don't have to do that, right? That's a commons construction, and that's often a useful construction. But you know, seeing as the row is it's a collection of rows. So if we let me see, do I have a CSV file in this here somewhere? Example.csv. Yeah, okay. So let's just grab this bit. Useful. So if we have a syntax error. Oh. Needs to be also it needs to be in quotes. That also needs to be in quotes. I don't know why the quotes didn't come through, of all things. Yeah. So it prints each of these rows, right? But what happens if we just print everything? So print grades. Get a CSV Reader Object. Now, maybe we can convert that to a list, and that'll allow us to index it. We might also, yeah. So might actually be able to directly address this thing. Let me see. Oh, not subscriptable. However, it will be if you convert it to a list. So if you list convert the thing that you read out of the CSV file. So, you know, when you read it, when a CSV object reads it, you get a CSV Reader Object out of that, right? And kind of similarly to how the range object is kind of like a list, but it's not really a list, but it behaves like a list because it has many of the similar sort of methods defined on it, defined as lists if you go into the class structure. In the same way, the CSV Reader Object has a lot of different things defined for it that are similar to, you know, a sort of list of lists construction. However, if you want to actually use it as a list of lists, then you perform a explicit list conversion, and then you may index it the way that you might expect to be able to. So there you go. Does that answer your question?
Yeah, that answers my question. Thank you.
You're welcome. Always keep in mind, you are the master of the data. The data is not the master of you. Or perhaps I should rephrase to say the difference between a good programmer and a not so great programmer is the not so great programmer is mastered by the data, and the great programmer masters the data. Cool. So, any other questions? Nobody? Going once, going twice? Speak now or forever hold your peace. Okay. So, just some closing notes then. So in general, the way that I recommend people write exams is to always sort of think about the number of marks that their response is worth, like their test paper as a whole is worth. You're trying to maximize the number of marks you have on the page at any given time, right? So think of your marks over time as being like an exponential sort of think of it like a logarithmic function, or looking like a logarithmic function. You want to be putting the most marks on the paper at the beginning of the exam, and then by the end of the exam, you're sort of asymptotically approaching whatever your final grade is going to be. That's kind of a overly mathematical way of saying do the stuff that's easy first that you know how to do. Especially if that stuff is worth marks. The stuff that you can just crack off quickly, do that stuff first. Because the danger of doing stuff in the order it appears on the exam paper is you might get stuck on a problem, waste all kinds of time on it, and then get a poor grade as a result. This is sort of, this advice is perhaps more applicable when you're like with a far more time constrained sort of proposition than this exam is going to be, but I think it's good advice anyway. So, if you feel yourself getting stuck on a question, move on to another question and then come back to it. Your unconscious brain will be working on the problem while you're working on other things, so you might come back to it with a different solution than you might have had otherwise. And yeah, that's, in general. Good luck, everyone. I hope that you guys find this, I hope it isn't too bad. That said, I hope that you guys feel like the exam has been a good final boss for the course, shall we say. So, yeah. I'm going to stop the recording here, and we can all be on our merry way. Thank you very much. It's been a wonderful semester, sort of, I would have preferred to have this semester in person, but, it is what it is.